When you are trying to find unknown sides or unknown angles in a triangle that is not a right triangle, an oblique triangle, there are two formulas that you might use to solve the triangle. One is called the law of cosines and one is the law of sines. Which one you use will depend on which information you're given. For example, if you're given all three sides, if you're given side, 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 you're going to use the law of cosines. Or if you're given side, angle, side, then you will use the law of cosines. You will use the law of sines if you have either angle, side, angle, or if you have angle, angle, side. But there's one additional time when you use the law of sines, and I'm going to put an asterisk on it because it's very special. It's called side, side, angle. All right, when you have two sides and the angle that is not between them, this is called the ambiguous case. All right, this is called the ambiguous case. And it's called the ambiguous case because sometimes you will have no solution, and sometimes you will have one solution, and sometimes you will have two solutions. And we just won't know unless we do a little bit of extra work. This video is all about this third situation. This video is all about when you have side, side, angle, the ambiguous case. For number 51, I see that we have two sides and an angle. So that means this is either going to be side, side, angle, or it's going to be side, angle, side. All right, which one is it going to be? Well, I have a shortcut for knowing if it's side, side, angle. If the angle matches a side, that's when it's going to be side, side, angle. Man, I'm saying, oh man, because that means this is the ambiguous case where it could be two solutions or there could be no solution. So it's going to take a little bit more work. So buckle in. So the first thing you should do is take your one angle that you have, put it on the lower left-hand side of the picture, like this. All right, so this will be our one angle. So this is the 20.5. Show this side across from the angle as a dotted line. This is the rope because we picture it swinging back and forth. This is what makes it all ambiguous, unclear. So side A would be right here. That will have to be 12. The other side they give you is this leaning side, like a leaning tree. So let the tree be the other side you're given. So we'll put the 31 here. So if that is side B, that means this is angle B, which means that this is angle C. So the first thing we have to do is figure out, is the rope long enough to reach? Will it make a triangle at all? And so what I do is I figure out what the height of the triangle is. So this is the height. I'm going to call it H. If I were to do the sine of 20, that would be the height divided by 31, because opposite over hypotenuse. So multiplying both sides by 31, I see 31 sine 20.5. That should equal the height. So I put that in the old calculator. 31 sine 20.5. All right, that is 10.9 approximately. So the height is approximately 10.9. So, is this long enough to reach? Is the rope long enough to reach the ground? Yes, it is. All right, the height is 10.9, the rope is length 12, so it is long enough to reach. So, that means there will probably be two triangles, because I'll get one triangle when the rope is in this position, or I'll get another triangle when it swings inward. However, to make the second triangle, it's important that the rope not be longer than the tree. If this were longer than 31, it would only make the one triangle. But the rope is long enough to reach the ground, and it is short enough to fit underneath the tree. So we will have two triangles. Because of that, because I will have two triangles, I will have to call this angle C1, and I will have to call this angle B1. And I will have to make another version of this triangle over here, okay, where I have all the same stuff, but this will be angle C2. All right, angle A doesn't change, because we already know that is 20.5. Okay, but we get the second triangle when the rope bends inward. Okay, so this will be angle B2. All right, the rope is still 12 in both pictures. The tree is still 31 in both pictures. Okay? So, now let's make a list of all the things that we need to find. We have one angle, so we need the other two angles. So we need to find the measure of angle B. You know what, I better move this down a little bit. We need to find the measure of angle B. We need to find, oh, well, I should say B1. We need to find the measure of angle C1. And we need to find the length of side C1. Okay, which is like this would be side C1, and this would be side C2. All right, so this is one answer box. All right, that's for the first triangle. But I will also need to find, of course, the measure of angle B2, the measure of angle C2, and the length of side C2. So this is a second answer box. Okay, what do I do? What do I do? Let's go after the measure of angle B1 first. So, when we have a side-side angle, the ambiguous case, we use the law of sines. Okay, whatever I'm looking for, I always put that in the numerator. So what I'm going to have is the sine of B1, because that's what I'm looking for, over side B, which is 31. Okay, and that should equal the sine of some angle. All right, well, the only angle I have is the 20.5, so the sine of 20.5 over 12. All right, in other words, the sine of A over side A. So I can easily solve this for angle B1. All I have to do is multiply both sides by 31. All right, so if I multiply the left side by 31, and if I multiply the right-hand side by 31, these 31s will cancel each other out. Okay? So that will leave sine of B1. If I want to find the actual angle B1, I need to do the inverse sine of 31 sine 20.5 over 12. all right, the inverse sine. So that's what I'll do now. The inverse sine of 31 sine 20.5 all over 12. So that is 64.783. degrees. Okay, now I can easily find the measure of angle C because they all have to add up to 180. And right now I have 2 out of 3 angles. So I can just subtract from 180. So if I take 180 minus the 20.5 that we had from the start, minus the angle I just found, 64.783, 94.717. Okay, that just leaves side C1. So once again, I'm going to use the law of sines. Just put a little line right here. Because I'm finding side C1, I'm going to put that in the top. So I'll put C1 over the sine of angle C1, which I just found. So the sine of 94.717. And that should equal, and I'm going to use the same fraction I did before, but this time I'm doing the side over the sine angle. So 12, I'm using the 12 and the 20.5. So 12 over the sine of 20.5. So I can get C1 by itself if I multiply by sine 94.717 on both sides. So sine 94.717. That way these will cancel out, leaving C1 by itself. So I can just put all of this in my calculator. So that'll be 12 sine 94.717 over sine 20.5. So that is 34.149. Okay, and they gave us units this time, so these are meters, apparently. All right, so we have solved the first triangle. Now it's time to solve the second triangle. Now here's the key. When you do this swinging rope to get your two triangles, ambiguous case, this angle, all right, the angle at the end of the swinging rope, and the new angle that you get after the rope swings, these two angles will always be supplementary. They will always add up to 180. Okay, so since I already have B1, I can just subtract from 180 to find B2. So I can just say 180 minus 64.783. And that's going to be angle B2, 115.217. Okay, now I can find the measure of angle C by subtracting from 180, because now I have 2 out of 3 angles, so I can subtract from 180. So if I start with 180 and I subtract the 20.5 that we started with, and I also subtract the 115.217 that I just found. I get 44.283. All right, that's both of the angles. So that just leaves side C2. So to find that, I'll just use the law of sines again. And whatever I'm looking for, I always put in the numerator. So I will have side C2 over the sine of angle C2. So the sine of 44.283. And that is going to equal, and I'm going to use the 12 and the 20.5 again. So that's going to equal 12 over the sine of 20.5. I can get C2 by itself if I multiply both sides by sine 44.283. Sine 44.283. All right, so these will cancel each other out. And that's going to leave, well, that'll just leave C2, and I'll just write it over here. So I'm just going to put all this in my calculator. So that's 12 sine 44.283 over sine 20.5. So that's 23.924. And that's it. We found everything that we needed for number 51. So looking at problem number 52, I see that we have two sides and an angle. That means it is either going to be side angle side, or it's going to be the ambiguous case side side angle. So I have a shortcut of knowing when it will be side side angle, and that is if the angle matches one of the sides, then that tells me it will be side side angle. So this is going to be the ambiguous case. So we're going to have to be extra careful. This is going to take a little bit more work, and we will end up using the law of sines. All right, when you have side-side angle, the ambiguous case, it's important that you be very careful in drawing your picture. And here's what I recommend. Take the one angle that they gave you, and definitely put that angle on the lower left-hand side of your triangle. All right, so here's my angle A they gave me. I will put that 85 right here. Across from the angle, make this a dotted line. I call this the rope because this is the part that makes it ambiguous. It makes it unclear, because maybe the rope will swing outward like this, or maybe the rope will swing inward like that. We won't know until later. So leave it as a dotted line. But either way, that has to be side A across from angle A, so that means this will be the 15 right here. The other side they gave you, see this side that leans? This is leaning like a tree, like a leaning tree. So make the other side always be the leaning tree. So since that was side B, that means this is angle B, which means this is angle C. All right, which means that this is side C over here. Okay, before we do anything else, we have to stop and make sure that this will make a triangle at all. And the way we check to see if it will make a triangle at all is by checking the height. All right, so imagine I call this h. I know that the sine of 85 is opposite over hypotenuse. So that would be h over 25. If I multiply by 25 on both sides, that gives me 25 sine 85 is equal to the height. So let's find out how long this is. So 25 sine 85. Okay. Uh-oh, that is 24.9. I'm going to round that to one decimal place for right now. All right, that is 24.9. And I'm saying uh-oh because look at this very carefully. If the height is 24.9, is there any way this rope is going to reach the ground? No, it's not going to reach because the rope, and that's why we drew it as a dotted line because we don't know yet, the rope is only 15. All right, if you have a rope that's length 15 and the height is 24.9, the rope will never reach the ground. It's too short. So that's why we have to say no solution, because there are no triangles that can be formed with this information. So we will say no solution. So that's how you do the ambiguous case. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.